Alright, so today we'll be learning a basic sort that we call selection sort. Selection sort is done by dividing the array into two parts, which is number one, the sorted part, and number two, the unsorted part. Before we begin the algorithm, the sorted part is assumed to be that that part of the array which is before element 0, which is basically nothing. And this is the unsorted array. After after one pass of the algorithm, we assume the sorted part to be till element number 0. After two passes, it is till element number 1, till after three passes, till element number 2, and so on till the entire array becomes sorted. Now, in the first pass, so what we do in selection sort is we select the smallest element of the unsorted array and place it at the beginning of the unsorted array. So, in the first pass of the selection sort, we need to select the smallest number in the unsorted array. So, beginning from element number 0. Okay, so right now the smallest element is 4. Then going on to element number 1, it turns out to be 3. On element number 2, it turns out to be 2. Then when we go to element number 3, it is equal to the current smallest number, so we do not change the smallest number. Alright, then going to the next element and the final element, which is element number 4. This number 5 is greater than the current smallest number, which is 2, so we do not change the smallest number. Now this selected card, we put it towards the beginning of the unsorted array. So after one pass, this is how our array will look like. This is the sorted array and this is the unsorted array. Now when we begin the next pass of the selection sort, we start from element number 1. So the smallest number in the unsorted array is 4. Then going on to element number 2, it's 3. Then it's 2. Comparing with the final element, 5 is greater than 2, so the smallest element is found out to be 2. So this is shifted to the beginning of the unsorted array by shifting the rest of the elements forward as it is. So one thing that we notice is that selection sort is an unstable array by seeing that this 2 is black and this 2 is red in the sorted array, whereas in the unsorted array the order was the red 2 was before the black 2. So an unstable sort is a sort in which if two elements are equal, then the order in the unsorted array is not maintained in the sorted array, which is true for the selection sort, so it is unsorted, so it is unstable. For the next pass of the algorithm, we start from element number 2. A smallest element is right now 4, then it's 3. Then comparing with 5, 3 turns out to be the smallest element. So simply 3 moves to the beginning of the unsorted array and all the other elements move forward. Now we begin from this element. Now this element is 4, which is smaller than 5. So this is the smallest element of the unsorted array. Moves to the beginning of the unsorted array. It was already at the beginning, so we do nothing. Now finally we go to the last element. Now since this is the last element, we have nothing to compare it with. It is already the smallest element, so it stays as it is, and this is the sorted array and a selection sort is complete. Now for the time complexity of the selection sort, we need to understand that we use another algorithm, the selection sort, which finds the smallest element in it. Alright, the smallest element in any array. So for the function which finds the smallest element, s of n is equal to s of n minus 1 plus o of 1, which is very obvious because if we have the smallest element in this array and we bring in another card, then to find the smallest element in the complete array, we just need to compare the smallest element of this array with this card. So s of n minus 1 plus o of 1, and s of 1 is equal to o of 1, which means that if we have only one card in the array, then we need a unit operation. Unit time complexity is taken to find the smallest element. So from that we find out that s of n is equal to o of n. Alright, and now from this we derive the time complexity of the selection sort. So t of n is equal to t of n minus 1 plus s of n plus o of 1, because for an array with n minus 1 elements, now if another element is brought about, The time complexity of n array element is the time complexity of an n minus 1 array element plus s of n, because now we are also finding the smallest element in an n member array, plus a unit comparison. And t of 1 is equal to o of 1, because if we have only one element in the array, it is already sorted. Solving this, we find out that the time complexity is O of n square. And with that, we complete our selection sort.